I'm going to start a mud and tailings tutorial using data from the Brumadinho tailings dam failure. And let's get started. So this is all going to start from scratch. We're going to start a brand new project with RiverFlow2D. To do that, I'm going to click on the new project button. I'm going to turn off all these layers, and I'm going to turn on the mesh density line, and also going to set this coordinate reference system to 31983. We're going to point to our directory here that we're doing the tutorial in. This is where all the tutorial files will be stored. And then create a new project. So we're the main screen. The first thing I need to do is load the digital elevation map. I have that ready to go here. We have two DEM files called raster Brumadinho and raster dam 10. And I'll explain what they are now. So I just dragged and dropped them into the layers panel. It's a quick way of loading them. Then I'm going to move them all the way down to the bottom. I'm going to right click zoom to this layer here. So we have two different layers. We have the tailings raster itself that contains the volume information for the tailings fluid, and we have the digital elevation map, which has been downscaled quite a bit. It's not a very high resolution map, but it's for tutorial purposes. So here we can see some of the depressions here in the terrain, and this will help us create our domain. So I'm going to go ahead and change the style of these. Right here on the right side, I have my layer styling panel on. And I'm going to go ahead and select Hillshade. The other one I'm going to leave alone so that you can see the difference. Now, next thing I'm going to do is I might shade this a little more. I'm going to change the Z factor so I can see it a little better. Let's change this to a 3. Okay, so now you can kind of see the depressions a little better. This will help me create my domain outline. So I'm going to go ahead here, click on the domain outline layer, and I'm going to click the pencil icon here, edit mode, and then I'm going to add a polygon. Now, I want to contain the area where I know the spill is going to be. So I'm just going to go around the tailings area first. I'm going to right click to close that, and we have a dialog that comes out. This is asking for the cell size. And here we're going to put 50. I'm going to keep them relatively large because this is a pretty big area. And now we have our domain outline. Since I can hardly see it, I'm going to go ahead and increase the width of the stroke for that line. Set it to 1. Now we can see it a little better. You can change the color here if I wanted to. And now that I am satisfied with this, I will go ahead and save and get out of edit mode. The next thing I'm going to do is I'm going to create a mesh density line. I'm going to click on this layer. And the reason why is to give the channel in the middle more triangles. We're going to densify it a bit to give us a little more detail and where the spill is going to occur. So I'm going to go ahead and edit and then click on the add line feature button. I'm going to start from the beginning here of the raster for the tailings. And we're going to start clicking. I'll just stay in the middle of this channel here. It doesn't have to be perfect. I'm going to right click again. And I'm going to set this to cell size of 25. And since these are lines, if I want to add a little more detail here, I just have to create another line. Right click, 25, and bam, we have our line. I'm going to make this thicker as well. The color is a little hard to see, so let's give it, I don't know, something a little more bright. There we go. All right, we got our mesh density line. I'm going to save this, get out of edit mode. And the next thing I'm going to do is set up some boundary conditions. Now we have a small river down here. I believe it's called a paraboa. I know I got that wrong. Here it is. It's Paraopeba River. Okay. We're going to set up the conditions for that. So the first thing I'm going to do is I'm going to have my boundary condition layer selected. Click edit mode. Add polygon. And then I'm going to add a polygon down here surrounding the edge of my domain outline, right over the edge and where the inflow will be. I'm going to right click. And here I'm going to tell it this is a discharge versus time type of boundary. I'm going to pick the file. And this will be inlet1.qvt in the tutorial folder. And this has been altered to have a higher discharge than normal because we want this channel to fill up quickly so that by the time the tailings arrives, there's a working river. And then once I see that that's there, just double check the data is correct. And then I'll click OK. And now we have our inlet. And then we need our outflow boundary, which we will put out here. So I'm just going to draw this whole area here. Right click to close. We're going to call this just a regular free outflow. And we have to do nothing else here, so click OK. Now we have our boundary conditions. I'm going to save this and get out of edit mode. I'm going to zoom back in. Now, the next thing we need to do is create a Manning's end layer. And this is going to be a simple polygon that surrounds the entire area. We're not going to give it any detailed Manning's information. Since this is just a tutorial, we want to just set up our model. But we're going to have to go ahead and put this in edit mode. Another way to go to edit mode is right click on the layer and then click toggle editing. Click on the add polygon. And I'm just going to draw a huge polygon, just making sure to cover the entire domain area. I might have messed it up a little bit, but I'll fix it. Nothing crazy, just enough to cover everything. Right click. I'm going to give it standard Manning's here of 3.035. And not worried too much about seeing that polygon, but I can see here it's not going over. So to fix that, I'm just going to click here on the vertex tool. I'm going to double click over here on it to create a point and just move it. And now I'm done. I'm going to save it, get out of edit mode. I'm going to zoom back to here. Okay, so we have our mannings, we have our boundary condition, mesh density line, and domain outline. The next piece is to create a mesh for the domain. To do that, I'm just going to click on the generate tri-mesh button. And now we have a mesh. And you can see that the cells get smaller on the line, and then they get larger as they go away from the mesh density line. And this should give us a sufficient amount of accuracy for our tutorial and keep the number of cells relatively low so that the calculations can be performed quicker. So the next part would be to let's try and get this model running with the basic tailings model, just to get a feel for where all the flow should be and to make sure that our inlet is generating our river correctly and so on. So let's go ahead and click on the export files to RiverFlow2D drop down and click on the export to RiverFlow2D button. Now we're going to give this the same name as the tutorial name, Brumadinho. Just going to call it Brumadinho. It's in the correct project directory already. The raster that it needs to look at for our elevation data is raster Brumadinho. That's the big raster here. And then we have to click on options. And then we have to click using initial WC raster layer checkbox. This is going to tell the model, hey, use this dem, this raster, for the tailings volume data. And then I'm going to click OK. Now we have our RiverFlow2D data input program open. And most of the options here are okay. I'm going to give a few more output intervals within the simulation time of 2 hours. And I need to turn on the mud and tailings module. Okay. We can always turn on these other options, but for now we're going to leave these the default. And since I already know that this is going to compute much faster on the GPU and I have one available, I'm going to select GPU. It's going to read the initial water elevations from the fed file. It's important that it sees that for the mud and tailings part. And then I'm going to click on the mud and tailings flow window. Here, since I know that the flow is going to look much closer to the actual event, I already know these parameters should be set a certain way. So I'm going to just change the flow resistance to simplified Bingham. I'm going to do the viscosity calculation with the silts and clays. Actually, yes, for silts and clays. And then here I'm going to pick as yield stress, we're going to pick the 95% silts. This is going to give it the lower yield stress. And this is the constant properties model, which is the basic model. And This will give you very basic outputs. You will not be able to produce certain maps that you can produce with the variable properties because it doesn't account for certain interactions, but we'll get into that further into the tutorial. I'm going to go ahead and save this mud file. Click on save. I'm going to leave this name that it's picking, Brumadinho, because it's going to look for this name. I'm going to save it. And then I'm going to go back to control data. Just give this a once over. Everything looks good. And then we're just going to run RiverFlow2D. It's going to ask to save. I'm going to click yes. I'm going to pick the same DAT file that we're using for the project. And now the model should start. There we go, our model window is showing us an output. See our river got generated. And there should be a mixing going on right here where the mud entered the river. All right, so our simulation is done. Took 49 seconds. On CPU, this would have probably taken about 6 to 7 minutes. And this is on a computer that has 24 threads of CPU to run it on, which is a good amount of CPU cores. And the GPU just does this much faster. So if you have a GPU, an NVIDIA GPU, that's the way to go. Go ahead and close this. I can close this window. No, not save changes. So we're back in QGIS, and we can take a look at some of the outputs that the model gave us. So I'm going to go ahead and turn off this tri-mesh layer and the domain outline mesh density line and boundary conditions. So we can go here to the results versus time maps, and we have a couple of options here. We can generate just regular results versus time for every time step. To do that, we click on results versus time. Now we're going to point to the out files for the run. And now you have a bunch of options here. You can look at the velocity field, velocity magnitude for each one of these intervals. So I'll just use the typical example. I'll do a depth for the final time step here. And you have the option of cell maps or raster maps. And for the raster maps, you can give it a resolution. So go ahead and output that. And now we have a depth map. And as you can see, we can invert this. But there you have it. That's a depth output, right? But this is just a basic mud flow model. So you're not getting yield stress information. You're not getting the viscosity information. This is all already just mixed as one fluid. So this could be used for, you know, much a simpler model where you don't require to know the components of said fluid. you just want to see maybe a trajectory and some depth, and you have an idea of you know, what the mixture looks like. So with that said, I'm going to turn this off. There is another way to run the model if you do not have the raster, this raster here that I'm going to turn on and off for the tailings. You can have, instead of the tailings raster, you can have a initial water surface elevation polygon. So in order to do this, we need to have some information like the highest point of the tailings and whatnot. Since I already have it here, I'm going to use this profile tool. If you don't have it installed, you can just install it from the plugins menu and then look for the profile tool. I'm just going to do a profile from here to here. Double click, and then I need to select this raster. Now it's not going to show me anything because I went outside of the boundary, so I'm going to redraw this line inside. Highest point here is 946.87 meters, and it drops all the way down to 600, so that's quite a significant amount of volume here of tailings. Now I'm going to go ahead and just do a few profiles just to see where the highest points are. Okay, so 940 meters is about the height that we want. Okay. I'm doing one more here. No, I went outside. Do it again. Okay. Yeah, so give or take 941.5, 943 in the back. So what I'm going to do is I'm going to create a new layer to represent this tailings, because this is sometimes not available. So I'm going to create a new layer by going to the RiverFlow2D toolbar, clicking on this drop down and clicking new template layer. I'm going to select initial WSE and click OK. Now we have this new layer here, initial WSE. And then what I'm going to do is I'm going to draw a polygon by editing and clicking on the add polygon tool. And I'm going to draw this tailings, and I'm going to give this a water surface elevation of 940 meters. So now I have a polygon that represents a 940 meter tall area, starting from the digital elevation model elevation data inside of this polygon all the way to the 940 meters, and it will put in that volume inside of the tailings. Now this is not very accurate because this is a flat surface, right? And we saw in the terrain profile that this is not the case. This drops down significantly going to the front of it, but you got tailings over here. So we have this whole area over here that is going to be added as more tailings fluid. So that's the drawback with using this polygon, but it's here in case it's needed. So I'm going to save this. I'm going to close editing mode. Let's turn off this profile tool. We don't need it anymore. So I've disabled that raster. I've left this enabled. I'm going to re-enable all of my layers again. And let's give this another shot. I'm going to go ahead and export to RiverFlow2D. Make sure that this raster is selected, and then click OK. All right, so we're back in the dip program. All the parameters are going to be the same here. Now, I'm going to go to the Mud and Tailings Flow module. Just make sure everything's the same. And the model should detect that initial water surface elevation polygon now and use that with the Mud and Tailings module. I'm going to go ahead and run it. I don't need to save anything. And there you see that the tailings was able to do we were able to do the tailings with a polygon rather than the raster. And we'll let this finish. So I'm going to highlight what I was talking about with that water surface elevation. If I go here and I use the RiverFlow2D cross-section tool, I can draw a cross-section here. I click once and then I double click to end it. It's just going to show me, you see how we have the volume here at 940 meters. It's a completely flat surface across the entire surface. This would not be the case with the raster. In the raster, you will see the differences in elevation. So this can have a lot more volume than the actual terrain would have. So this is just another way of seeing that. And when we go to the first time step, you'll notice that it completely falls down. Boom. Just goes all the way down and empties out. So it's just another way of looking at the difference between those two methods. So we're going to go ahead and just disable this. And I'm going to re-enable the raster. And now we are going to set up the variable model. In order to do that, we're going to introduce a few different concentrations. We have to point to a different mud file that we have prepared for this tutorial. And I'll go over a little bit of it just to have an understanding of how it works. And we will do that from the dip once we've exported with the raster enabled. So I've enabled the raster again. I've disabled that initial water surface elevation. I'm going to turn on all my layers again. And we'll re-export it. making sure I select that initial raster layer and making sure this is set to raster Brumadinho. Okay, so now that we're back in the dip, the first thing I'm going to do is show the mud and tailings. We're going to enable the variable properties model, clicking on the radio button, and this changes a bunch of stuff here. Basically, now you're allowed to add sediment classes for each type of sediment class that's in your tailings. This allows you to set different densities of each of those classes, the volume concentrations for each, diameters, the bed material porosity, critical stress. We can use different formulas for the settling, for equilibrium concentration, and the same flow resistance relation from the basic model, and these other formulas as well. So I'm going to go ahead and open a mud file we already have prepared for this called Brumadinho Dam. This will load the parameters for this particular tailings. There's a total of 6 classes here, with all of these variables. It's important that this bed material fraction between all classes does not surpass a total of 1. So right now we have it split between class 1 and 2. Initial volume concentration is going to be set from a layer that we need to create. So we're going to go back and do that now. Another important thing, when you change to the variable properties model, before going anywhere else, so I've loaded the properties that I want. Now I need to save this as the same name as the project mud file, because that's the one the model will use when it runs. Go ahead and overwrite the one we have. And now I'm going to click on Open Boundary Conditions. When I click on the first one, the discharge versus time, this is our inlet, we get an error message, or an informational message rather. So basically, the model needs to know the different sediment classes. There needs to be columns for them in the inlet file that we have here. So RiverFlow will add these for you to avoid errors. So it's going to add those columns. They're going to put zeros because we don't want any of that, any of those concentrations in our river inlet. I'm going to say yes. And now we can see that it's creating those. I'm just going to click save. I'm going to go back to control data, and I'm going to close this for now because we need to go back to QGIS. Now back in QGIS, I need to create that layer for the initial concentrations. So I'm going to go ahead and click on new template layer, and I'm going to click initial concentrations, and now we have the initial concentrations layer. I'm going to put that in edit mode, and I'm going to draw a polygon over the raster here in the tailings side of it. This is just a rough polygon. Try to stay inside of the raster, as close to the edge as I can. And I'm going to stay here in the lighter area because we're going to set the concentrations in this area. And now I need to pick a file. We already have a file in the tutorial folder for this called deposits initial.txt. I'm going to open that. Click OK. Save it and get out of edit mode. Now that I'm done, we'll re-export it. Make sure this is selected. And this is turned on. All right. So now what's going to happen is this initial volume concentration in the file is set to 0. But now that we created the initial concentration layer, instead of looking at the mud file, it's going to look at this layer instead and grab the information from there. So now that everything is set, we're going to run it. We don't need to save that because we haven't changed anything on this panel. Okay, so that finished. All right, now back in QGIS, we're going to be able to generate a few different outputs here. I'm going to turn off all these layers. I'm going to go ahead and add some satellite imagery for the area. Now, you may or may not have this installed, but there's a plugin called Quick Map Services. You can just search it here, install it, and then once it's installed, you can access it here. I usually load up the Esri satellite map just to make it look nice and pretty. And to make it even prettier, I'll put the Esri above everything else. And then here in the raster, or rather, I think the Esri, I multiply this. And I can kind of give it the shading from the raster. This looks good if you were zoomed in, but it darkens it quite a bit. So you can mess with the satellite and give it some brightness there. You know, make it look a little more. But I'll just turn it off for now. We'll use the map. So we've got a map of the area, and I'll go ahead and start showing some outputs here. So if we go back to the results versus time maps, when we load up the out files, see we've got our regular maps. But now we have access to concentrations and properties versus time maps. We go ahead and pick our mud file. And now we have a few maps here to look at. For every concentration that was set inside of the run, we have a concentration here. Concentration 1, 2, 3, 4, 5, and 6. These are separate maps for each particular concentration of material. So, for instance, I want to see the last snapshot of concentration 1 and 2. Let's do it again. 1, 2. Okay, 1 and 2. Separate. Let's get a total. So we can see the different outputs. You can see you can also do density, viscosity, and yield stress for the mixture, not for each. And now we have a bunch of different outputs. Let's go one by one. So here we have concentration 1. So we have that output. And this tells you how much of concentration 1 was inside of the spill. We can do concentration 2. This had less, it looks like. And then the total of the different concentrations. We can animate all this stuff using the animation panel. Oh, we got to animate it, but we can't do that until we save our project. So very important. Go ahead and save it. I'm going to call it just Brumadinho and take the 1 out. Actually, this is in the wrong folder. We'll save it here. Now we can use the animation panel, which comes out down here. Select the layer. If we want anything from the mud and tailings, we have to select mud and tailings. And when you click add layer, you get a dialog that asks which one do you want to see. And we'll just do a concentration 1. Select the start and end time. We can customize this to whatever time frames we want. And here's a loading bar, progress bar rather. This animation panel comes out at the bottom usually. You got to drag it above the satellite. And now I make sure that this is turned on. Click on this here on the layer in the animation panel, and then press the play button. And we can see every frame. We can adjust the speed here by just moving this up. And this concludes the tutorial for mud and tailings using the Brumadinho tailings failure. Hopefully this has helped you understand a little bit of how to set up this model. And as always, if you have any questions, please send us an email at support@hydronia.com. Thank you for watching.